I'm very happy to be here, and I'd like to thank the organizer to give me the opportunity to talk about this work. I work at the University of Amsterdam, and today I'm going to present some work that I have been doing in collaboration with people at the Leiden Observatory. In particular, I just gave a keynote talk at the Nanoscience Cost Action here in Istanbul, and the motivation behind my talk was I want to raise awareness about the importance of top-down chemistry in the interstellar medium. For the way astrochemistry has been evolved, we always have been thinking how we can make a complex molecule with the simple atoms that we can find in the interstellar medium. And so now we know that these networks of starting from small atoms and growing up, the so-called bottom-up approach, works very nicely and can explain a lot of the molecules we see in space. But my question is, what happens when you are confronted with larger molecules like fullerenes of polycyclic aromatic hydrocarbons? They can resist in very in environments that are irradiated with a lot of UV photons, and so they can be destroyed. And they can be the starting point of what I call top-down chemistry, and together with me, many other researchers. And so the release of carbon atoms and hydrogen can make these atoms available for other reactions to happen in space. And also, if you can create, from the breaking down of this molecule, smaller hydrocarbons that are resilient enough in space conditions, they could be a good way to explain some of the unidentified features that we have been seeing in astronomical spectra, for example, the diffuse interstellar band. So at the talk, I explained some of the results that we had, looking at different classes of this molecule, investigating different isomers, investigating size and the role of curvature. And for me, it's very important to show that this is a collaborative effort, that you really need the experiment and the theory if you want to bring further your knowledge and understand what's going on. And I hope that this cost action is going to be a place where more of this collaboration will arise and will bring further our understanding of nanocarbon in space.